Hello, everyone. Good afternoon. I hope that you can all hear and see me. We had a small little technical problem starting up. Apologies for that, but we are here. Welcome, everyone, to this third episode of Delta Dialogues. Delta Dialogues is your monthly call to get up to speed with all the recent developments in the integrated photonics industry. Well, my name is Johan Smeets. I'm going to be your host today, and we'll have a nice little lineup for you with some very nice speakers that are going to introduce you some interesting topics. Let me quickly go over that before we start with our first speaker, who is waiting here next to me, Rick Jongen. Thank you very much. So we're going to start with Rick. Rick is from HighTechXL. HighTechXL is a venture builder in the deep tech world, but he's going to tell us all about that later. After our interactive discussion with Rick, we're going to 3 pitches. The first one is going to be from Marcela Gallardo from The Gate. The Gate is a startup accelerator located at the Eindhoven University of Technology, not so far away from here. Second will be Frank Smith from Pilot Photonics. Frank is the CTO, and he will tell us a bit more about what's happening in their organization. Then, last but not least, from the pitches, we'll have Bart de Boer, apologies. Bart is the CTO of Delta Diagnostics, in a very interesting startup that's making biosensors and devices for point-of-care diagnostics. After those 3 pitches, we'll have an inspiring keynote from no one less than Stefan Hengesbach. Stefan is the recently appointed CEO of QuiX Quantum. If you have any questions, please drop them in the chat. My colleague will forward them to me on my device, and I will be able to interact with the speakers and get your questions answered. Also, if you want to take part in the next Delta Dialogues, you can do that. Just go to the website of Photon Delta. At the event section, you will see the Delta Dialogues one. There's a form in that page that you can use to fill out if you want to speak about something, a keynote, a pitch, or whatever, and we can then take that into account when we plan our next one. So this Delta Dialogues is going to be, let's say, the last one before the summer holidays. Then we'll start again in September, and that will be on the 7th. With no further ado, I would like to start with the program. So thank you all for calling in all today. The first speaker today is Rick Jongen. Rick, thank you very much for coming into the studio today. Your office is not very far. It's just a couple blocks down, but still appreciate it that you could make it here live in the studio. Rick, how are you doing today?
I'm doing fine. Thank you for asking. Yeah.
Okay. We have some interesting questions, I think, that are going to be covered today. Maybe for the people that are in the audience and that don't know much about, what is HighTechXL, what do they do? Can you maybe give us a little introduction?
Yes, of course. Yeah, HighTechXL is a deep tech venture builder. So we focus on explicitly on the hardware things.
Mm-hmm.
On the one hand, we scout talents, so entrepreneurs with, on the one hand, a business background or a technical background.
Yeah.
On the other hand, we are also scouting technologies which have the potential to disrupt existing markets or create entirely new ones. Integrated photonics is one of them. Therefore, we mix them. So the entrepreneurs and the technologies, they will enter our hackathon. So it's an event where a full day event where they have the opportunity to brainstorm and develop a business case. After that, they have 2 weeks to develop or further fine-tune their business model. And then they need to pitch it to the HighTechXL board on what we call a final selection day. When they pass that moment, that day, then the real magic starts to happen. So then they will enter a 9-month venture building program where they got workshops, deliverables, and the connections to validate their business case. So as well on the market side as a technological side.
Mm-hmm.
When that is done, which is mostly within the first 3 months, they will further expand their efforts. Mm-hmm. And also focusing on supply chain and other aspects which you need as a deep tech venture.
Yeah.
So when you enter the 9 months, the fundamentals of deep tech business plan are in place, and they can further scale.
All right, great. And do you know how long has HighTechXL existed? You look at it here on the campus, right, in Eindhoven. How long has this been initiative going on? Do you know?
The venture building approach is going on for now almost 4 years.
Wow. Okay.
Before that, we started as an accelerator program. By that time, we had a 3-month program. However, when it comes to deep tech, we saw that way more time is needed, and more help is needed to get such hard technology, and most scientifically based, needs more effort to take it to the market. Therefore, we extended our program from 3 to 9 months, and we start the venture building approach to help those technologies and the solutions which are created in the universities and the R&D labs of multinationals to solve the problems the market and the industry is facing.
Okay, so you basically take innovation that has been created somewhere in a knowledge institute, in a university, or in a company, and you take that whatever is sitting there is not used, and you try to convert it into a startup.
Yes, indeed.
Okay, all right.
So most of the times our partners don't want to take the risks, so then it's where we came in.
Yeah, and why is it so important that that an organization like HighTechXL does what it does? Why do you do what you do?
Yeah, so we focus on the applications which are maybe not that top of mind for a specific technology. So when a technology is developed for an application in aerospace, for example, we can have a startup which also validate that same USP, so the unique properties that technology has, in other market segments or other applications or niches, and therefore increase the effectiveness of the innovation and the research time those parties had taken in that, and get the full potential out of those interesting innovations.
Yeah. So it's also about making an impact, right, with these deep tech innovations that maybe otherwise would never see the light of day.
Yes, indeed. So that's also why we are explicitly focusing on the Sustainable Development Goals and societal impact. So that's also one of the KPIs we are focusing on. So sustainability is quite an important topic, and that's also what the advantages of the venture building approach is, that we can help those new ventures to embed that in the root of their thinking and the root of the business.
Yeah. All right. I think it's very well, let's say a good thing that there's organizations like HighTechXL. Maybe you can elaborate a little bit on your approach and also how that makes you different from other, let's say, venture builders or accelerators. Can you tell us a bit more about that as well?
Yeah, regarding so the first difference is that we are a venture builder, so we do not source applications. So we source technologies which has a lot of potential, and also scout entrepreneurs, and then the entrepreneurs are totally free in their choice about what they are doing, which societal problem, of course, they are going or wanting to solve with that technology.
Yeah.
So that can be in several different markets. So we are not focusing on, for example, the agriculture, or focusing on and excluding therefore other interesting applications. So that's already a difference.
Yeah, exactly.
And also then, that our program is 9 months is also quite unique. And therefore we are also in an earlier stage than an accelerator. Most of the projects which came out of our pipeline can then go to an accelerator program dedicated to a specific market segment. So then they can further increase their network in such a program.
I'm also very curious to know more about some maybe examples of startups that you have created already. But maybe before we go into that, let's look at, of course, the link between HighTechXL and also the integrated photonics industry. You guys started collaborating with us and looking into using this technology maybe I think a year ago when we started working together. Maybe a little bit of background for the audience on why did you guys start to dive into this technology?
Yeah, so the supply chain is getting mature, and we saw that the amount of applications which are coming out every year, which is already increasing and very promising. We saw that, okay, with our background in deep tech, we would love to help to accelerate that amount of applications. So that's also for the people which are not familiar with the integrated photonics advantages. Can be more explicit by developing faster, more use cases.
Yeah.
So when we saw that those developments and also the efforts Photon Delta is putting in, we want to be part of that ecosystem. Also, when we saw that the ambitions of 200 startups the coming years was stated in the growth fund application, we wanted to be part of them and help to achieve that large ambition.
Yep.
So from that perspective, and also, yeah, we saw quite some synergies, and therefore, yeah, we are we went into integrated photonics.
Yeah, and that's also for the people that are looking and maybe are not aware of this the growth fund proposal that Rick is referring to. He is right. We have a big ambition by 2026, creating 200 startups that make use of the technology, and that's also why applications that can make use of the supply chain and ramp up volumes. Because as you said, the supply chain is ready. Now it's time to bring the products to market, and for that we need companies that are in contact with the market and that know the applications, of course. So that's I think that's a very interesting point. And maybe, as I said before, I'm quite curious, and I think also the audience is curious to know, like, what are some of the examples of startups that you guys created? Can you maybe give us a couple?
Yeah, so we are already a longer time in the photonics. So, for example, Alcision, which presented in the first Delta Dialogues, is one of the companies who came out of HighTechXL. Also, Infocal is a photonics company, an optics company, which came out of our program. So therefore, we have already some contacts and network in the photonics side. But yeah, we missed a bit, and we want to expand our network in the integrated photonics because there are differences. Also in the way you use the connections and work with your connections. So from that point of view, those are two use cases, and also we have other use cases which are now starting to work with integrated photonics.
Okay, and that's then the integrated photonics ones, but you also historically, I mean, you've been covering a lot of different other technologies as well, right?
Yeah.
And I think recently there was something in the news about one of the startups that you guys created that won a prize from Elon Musk, if I'm not mistaken.
Yes, so that was Carbion. So Carbion won the X Prize. So Elon Musk wrote down a global contest about how you can remove or capture carbon dioxide out of the air.
Yeah.
Around 1,100 projects worldwide applied to that contest, and only the top 15 got 1 million each. And Carbion was one of the top 15 worldwide of the most promising solutions.
Wow, that's quite impressive, and I hope we're gonna get similar successes also with integrated photonics, of course. So maybe for the people out there that have an idea, or maybe there's some companies that are tuned in, or universities, and they have some interesting IP, but it's not part of the core strategy. They don't want to develop. How can they get started with HighTechXL?
Yeah, you can of course reach out to the HighTechXL people or me, if you like. From that on, we can discuss about the conditions and what the potential of the technology is and how how they want to work with us. We're very open. So yeah, we are based in Eindhoven, but we see also the great developments in the Twente region, for example, in Enschede and Delft. So we are scouting also our technologies worldwide. So maybe technologies which are developed in America, for example, needs additional knowledge which our ecosystem can be helped with, or connections. So there are no limits in terms of the boundaries, and therefore So if you want to extend the impact of your IP or maybe work together with us, feel free to reach out.
All right, very good. So and I think there is a new cohort coming up also. That's October, if I'm not mistaken.
Yes.
So that's when this 9 months of incubation starts, or?
Yeah, we start 2 programs every year. So one in end of February and the other in October. From there, and also now with the announcement and the collaboration with Photon Delta, we are also focusing on the next cohort more on integrated photonics, and want to have more companies which are working in integrated photonics. That we can help them to the market. So in this case, even projects can be let into our program, so we can help with those businesses, or ideas are always welcome. And also technologies for the next cohort, which will start in the end of October indeed.
All right. So if you have any interesting inventions laying around, you don't know what to do with it, please get in touch with Rick Jongen. Yes. We will share your contact details maybe in the chat, so that people know where to find you, of course. But also if you go to the HighTechXL website, I'm sure you'll find also some contact details there. Maybe also good to conclude with, because we're running a little bit behind because of the technical problems we had earlier. In November, we will have on the 7th and 8th, we're organizing a big photonics event in the Netherlands, and HighTechXL will be a partner in that. We will do some interesting stuff there also for startup creation. So make sure that you stay tuned, that you check your mailbox, because I think in the next week or so, you will be receiving more information about that. Rick, is there anything else that you think we have not covered and we should cover?
No, I think we covered everything. So an open invitation for all entrepreneurial minded people who wants to build their own venture with integrated photonics, or have an idea to build a team around that and also build a business. So also those people, so not only technology, also entrepreneurs, feel free to reach out. Maybe we can do something together.
All right, thank you very much, Rick.
Yeah, thank you.
The next speaker of today is Marcela Gallardo from The Gate. First, of course, I would like to thank Rick very much for his input today. I think it was a very interesting presentation. Feel free to reach out to him. If there is any questions, also during the presentations, feel free to drop them in the chat so we can already look at them and ask them to the various speakers. So Marcela, if everything went okay, you should be unmuted. We should have your video and you should be able to share your screen. Is that correct? Can you hear us?
Hi all. First of all, thank you for the invitation, and I'm really happy to be with you. Share about The Gate, a multi-platform service provider for valorization and startups takeoff. So I prepared indeed a couple of slides to help showing what we do.
Okay, great. And just for the record, Marcela, you joined The Gate not so long ago, right?
Yes, I started on the 1st of April this year. And I come from industry, and I'm very excited about the possibility to use my background, let's say, in my current role, and do something with it.
Yeah, all right. Well, we're looking forward to your presentation, Marcela. You can go ahead.
Yes. So my first slides is about where we are located. I think this is a very, very important opportunity for us. The Gate has been launched officially in January 2021, located in the Alpha building of the campus of the Eindhoven University of Technology, where science meets business, and it is indeed, it is not an understatement, and is embedded in the Brainport region, a proven incubator of successful startups. Most of the startups in this region comes from TUE, many today leading the photonic industry. And this has to do with the research and the education activities that take place at TUE. And the campus, it is a truly exciting place to be. When it comes to the photonics, the interconnects of the gate are simply powerful. This is the way actually the gate has been engineered. TUE, that is one of the major founders, has state-of-the-art facilities to perform cutting-edge research in the fields of photonics, but also other fields. We are integrant part of the multidisciplinary Eindhoven Hendrik Casimir Institute of the Photonic Integration Technology Center, PITC, and of the Strategic Integration Platform, JEPIX. You see also the all partners involved. So I don't have to mention more. We support and are aligned with the regional, national, and European photonics strategic agenda, and can navigate and work within the huge Brainport networks ecosystems, interacting with all these partners mentioned on these slides. And this interaction anyway is also facilitated by Photon Delta, the EPIC associations, and Quantum Delta. By the way, one of the partners we are in contact with is HighTechXL. I can maybe tell something later on. Was nice to hear the introduction before mine, the interview actually before mine. So, but why the gate? Now, it is not only about another to come up with, let's say, another venture builder. It is something different. It is actually an initiative for the entire region set by TUE, Fontis, Summa, Brainport Development, and the Brabant Development Agency, the BON. They all came together and to support anyone wishing to launch a startup. It's something that is very scattered and needed a change, especially when you look at the partners I've been mentioning, which are the gold mine of the all fantastic ideas that actually are the roots of the many successful photonics companies present now in the region, and not only because some are investing actually in other parts of the world as well. So the gate was created as a one accessible desk to all areas of expertise for the entrepreneurs, directly connected with entrepreneurs. And the target is to contribute to expand the startup ecosystems for key areas. Photonics is surely one of them. We look at the regional needs, but also national, and of course the ambition is international. And this also with the support of Photon Delta. The bond with TUE is very important, and I like to stress this because this helps to introduce to the market state-of-the-art technologies also in the field of photonics, because the industry wants to be surprised by new research. Yeah? So it's good to be there, to be directly in contact with these walking brains that are present at the TUE. The target groups of the gate are entrepreneurial students, scientific staff, tech starters. They are all welcome. And how do we work? So first of all, we focus on the early phase of the startup development. We use a very proactive business development approach, which is quite robust and successful. I can go into all the details if you have questions, but the companies that are here now on the slides are the results of this process. And along the way, we provide coaching, mentoring, all the valuable tools pertaining different fields to the entrepreneurs. We also offer incubator programs on basis of strategic teams. And surely we support till the startup is strong enough to run with their own legs. So we talk short pre-seed, seeds, and okay, part of the Series A part when it comes also to funding. After that, we still provide the support, but we act as advisors and network providers. And this is my final slide. I list all the tools that we provide at Gate. I like to only stress the validation of innovative idea and ideation management because we are now participating in indeed collecting new ideas and selecting the best and bringing those to successful startups in the future. So it's all starting exciting for me. I also want to say we are busy with new fundraising opportunities like Tech Ideation Fund Brabant and Entrepreneur in Residence programs, and all the rest is something that where we are very, very, very strong with building the business plan and legal support, IP, collaboration with other university programs. And of course, we have a new startup readiness program developed with all kinds of different partners to bring startups, let's say, to success. Behind this list, there is a highly qualified team, super enthusiastic. So on behalf of the Gate, we are happy to tell you more about what we do, the way we work. So please visit our website, subscribe to our newsletters, and thank you very much for your attention.
All right, thank you very much, Marcella, for this introduction. I think it was very, very clear. Maybe just also for my information and to understand also for the audience, I see some similarities also with HighTechXL as a venture builder. What do you think are the main differences? Is it that you are mostly focused on the innovations that are generated out of the universities, or?
No, not only. For sure, this is an advantage because we actually support the management of the IP portfolios of TUE. So then all the new technologies, all the new ideas, let's say, land to us. And we are, let's say, in the position to support from the start. We dedicate, like I said, at the beginning of the startup, of the setting of the startup. I think HighTechXL, because it's supported by VCs, is let's say in the position to offer a different support, more also at beyond the seeds. But it's a similar approach. We have been in contact with HighTechXL as well because in some cases HighTechXL has access to a much wider let's say type of entrepreneurs, of people with different backgrounds and ambitions, and they are very valuable when it comes to set successful startups. We may miss this, so the idea is to collaborate actually with HighTechXL to maybe join forces when we have something really valuable. Maybe finding new team members and making the team stronger and so on, let alone that the wish is to valorize all the best technology that are in our hands, and HighTechXL is also an opportunity, sure.
Yeah. All right, thank you, Marcella. I'm looking into the chat if there's any questions. So far, I think everything is quite clear. We will share your contact details with the people that are in the call. That can maybe be beneficial. And then if there's any questions after, they can revert directly to you, or if we receive any questions, we will forward them. Thank you again for your presentation today, Marcella.
You're welcome.
And then we are going to continue with the next speaker. And the next speaker is Frank Smith from Pilot Photonics. Frank, if everything is okay, you should be able to share your screen and unmute your microphone.
Perfect. Let me try now.
There you are.
Excellent.
Hi, Frank. How are you?
I'm good. I'm good. Thank you very much. Thanks for the opportunity to talk today.
All right. Where are you calling in from, Frank?
From Dublin in Ireland.
Dublin. That's where Pilot Photonics is located, right?
Yeah, we're headquartered here, and we have people then based in Spain, in the UK, and in Taiwan.
Okay, interesting. Good. Right. You should be able to share your screen.
I am sharing at the moment. Can you not see it yet?
Let me get quick. Check. Yes, we can see it.
Great. Okay,
The floor is
fantastic.
yours.
Thank you very much. Okay, so quick overview of Pilot Photonics, and then I'll talk a little bit about our technology and some of the areas that we're targeting. So we were established in 2011 as a spin out from Dublin City University, and we're still headquartered there in the Invent Centre, which is a business centre there on campus. We have labs and offices there, and then we also make use of other facilities and labs within the School of Electronic Engineering, and so access to kind of very high-end state-of-the-art equipment there, which is what has kept us on campus. The company really develops PIC-based solutions that tackle advanced challenges in numerous different industry verticals, including data transmission, sensing and measurement, precision timing, those kinds of areas. And we've got a patented comb source technology that we integrate into our photonic integrated circuits, and then develop solutions in order to tackle those challenges. We like to claim that we have a full stack photonics offering. So we work all the way from the kind of semiconductor material design through laser PIC design. We outsource fabrication to partners, including those within the Photon Delta ecosystem. But then we also have expertise and capability on electronics, the RF design, to drive these PICs with very high data rates, as well as some of the packaging side of things, digital and analog PCB design, and then as well all the way to the kind of control electronics firmware and software that's required to really kind of close out a full end-to-end system. So that's what we like to be able to deliver to our customers is not just the PIC itself, but the full suite to be able to access and exploit it to the maximum. So our customers, we work across a kind of very broad range of customers, from governments and agencies all the way through a number of tier 1, 2, and 3 companies across several different industry verticals. As I said, particularly communications, telecoms, and datacoms is a big area for us, but we're also active in sensing and in precision timing and areas like that as well. We've also a number of kind of global distributors, and we've sold a lot, particularly in the early days, to universities, where we sell like kind of comb source instruments to R&D labs. So that's a kind of a broad ranging customer set. And now a little bit, I'm going to focus in on, because we were limited on time, I'm going to focus in on one of the kind of areas that we, I suppose, our flagship technology development. So it's in the area of coherent pluggable transceivers, and basically a challenge facing that industry is how do you effectively pack 4 or 8 times more information into the same form factor, the same power density and things like that, as exists today. So basically a dramatic kind of upscaling of capacity with the same kind of infrastructure. And so we're tackling this challenge using our ICLA technology, that stands for Integrated Comb Laser Assembly, and then also Super TROSA, which is essentially a full comb-based optical engine. And we do that using our innovative patented comb technology that I mentioned earlier on, and that brings benefits to coherent networks of basically being able to reduce the complexity and the power consumption of the digital signal processing that consumes a lot of the power in those networks. Then combining that with dense photonic integration, almost everything we do is monolithic indium phosphide, and we co-design that with the DSP provider in order to minimize and kind of improve the signal integrity and maximize the efficiency there. And then we're also working on new modulator architectures that can reduce those PIC cost and size even further, particularly for the intra-data center market where those are huge drivers. So this is the Super TROSA. So TROSA, as anyone kind of familiar with the coherent comms market, stands for transmit receive optical subassembly, and we've trademarked concatenating that with super, which is for super channel. So a super channel is basically where you use multiple wavelengths to build up your data channel. The industry for the last, 20-30 years has always been based really on a single wavelength per channel. And these super channels are the way that the industry sees to continue to scale their data rates and meet the capacity demands of their customers and of consumers. So Super TROSA is the world's first coherent super channel optical engine that's based on optical combs. And as I mentioned, optical combs is a type of laser that allows has these unique advantages in terms of being able to simplify the digital signal processing, pack more data into the channel, and several other benefits that make this a nice light source to use for this market. And so this current chip delivers 1.6 terabits per second of data on 4 coherent wavelengths from a single indium phosphide PIC. The goal is at the moment, this is in kind of alpha form factor, alpha prototype form factor kind of, but the goal is to squeeze this into one of these OSFP XD sort of industry standard transceiver form factors, and we're working with our DSP partner to do that. So our technology offerings I mentioned earlier on, we delivered these kind of instruments, benchtop instruments, into R&D labs for customers who wish to kind of try the technology and prove the benefits of it in their labs. Then we have this integrated comb laser assembly, which is a PIC that will be integrated into essentially an industry form factor module, and our ICLA will replace 4 or 8 or 16 ITLAs, which are the industry standard kind of tunable laser that's used for coherent communications. And so this allows our customers to basically integrate our comb technology with their own either silicon photonic or indium phosphide based optical engines. So the optical engine is the modulators and demodulators basically. And then finally, we have, let's say, the deepest level of integration is where we integrate that comb laser technology into a much more advanced PIC, which fully integrates all of the modulation and receive optics as well onto a single PIC, and that's what we refer to as the Super TROSA. So that's kind of one of our that's like I would say our flagship technology development is in that area of coherent kind of very high bandwidth communications. We're also active in FMCW LiDAR, in fiber sensing for aerospace, and then we're doing a lot of work for the European Space Agency on atomic clocks and things like that. So very broad kind of offering there. And just to mention, to kind of close out, that we have we're already fairly deeply embedded in the photon delta ecosystem. So we've worked and we have business ongoing with several companies from your ecosystem list there. So very pleased to be a part of it, and only see those collaborations and partnerships growing. That's all I had. Short but sweet.
All right. Thank you very much, Frank. I think it was a good presentation. There's a lot of people reacting in the chat already. There's one question, but also people giving some remarks. Like Nuno, he's saying he's very impressed by Pilot Photonics. But we also have a question from Tobias. I think it's Tobias Harter. He's been also active in the previous editions. He is asking, for which applications outside telecommunication do you see the integrated frequency comms as enabling technology? Would your technology also be able to address frequencies outside the telecommunication bands? Well, I think one of the things you already mentioned was LiDAR as a potential application, right? As that you're working on, but maybe you can elaborate more on the question.
Yeah, so our technology is for comb generation is pretty wavelength agnostic. So basically anywhere that you have a semiconductor laser diode that you can directly modulate, we can produce a comb at that wavelength. So we've done for our atomic clock generation stuff, we're working down at 795 nanometers and 780 nanometers. We've also shown comb generation up at kind of 2.2, 2.3 microns as well. So yeah, the technology is quite versatile from a wavelength perspective.
All right. Thank you, Frank. I think that covers the question. If there's any further questions, we will forward them to you. We will also share your contact details with the people in the audience when we share the recording later this week, if that's okay with you.
Absolutely. Thank you very much.
All right. Then I would like to thank you for your time. And our next speaker is Bart de Boer from Delta Diagnostics. Bart is the Chief Technology Officer and should be able to unmute his microphone. Bart, are you there?
Yes, I'm here.
All right, great. Bart, I think it's interesting. Delta Diagnostics, you guys joined the ecosystem, I think it was last year, if I'm not mistaken.
Yes, that's right. Yeah, indeed. Yeah.
We are looking forward to share with the community more information about your organization, what you're working on, and your future. So if you could share your screen, and then you can start your presentation.
Yeah, I'll do so. And elaborating a little bit on what you said earlier, we're not necessarily working on point-of-care diagnostic tests themselves, but rather on the instruments that are being used in life science research laboratories for the development of diagnostic tests, and including point-of-care diagnostic tests. Okay, so my name is Bart de Boer. I'm the CTO of Delta Diagnostics. Delta Diagnostics is a spin-off of TNO. It was founded in 2018, and we are currently located in Rotterdam, in the Rotterdam Science Tower. And our mission is to deliver cutting-edge biosensing technology for both industry and academic research. So let me start with one of the problems that we can address with this platform. So there's currently no single biomarker that can be used to determine whether somebody has a bacterial or a viral infection. And the treatment is completely different. So one of our partners is trying to solve this with using a biomarker panel. And this is just one example, but it's clear that there's a trend in vitro diagnostics towards the use of biomarker panels, rather than relying on the detection of a single biomarker for diagnostics. So it's becoming more and more clear that detection of a single biomarker is just not good enough for reliable diagnostics. However, there are currently no platforms available that allow a fast and convenient discovery and validation of such biomarker panels. And as a result, this research is performed sequentially and on different instruments, which hinders the rapid development of diagnostic tests. So there are currently biosensing platforms that allow multiplexing, but are very labor intensive and very time consuming. And there are biosensing platforms that are fast and automated, but are extremely expensive and offer limited to no multiplexing. And our platform is in fact the only platform that can provide the best of both worlds. It provides automated and multiplex detection while still being affordable for any company that is active in this research. And we can meet this unmet need in life science research by making use of photonic integrated circuits, carrying waveguide-based sensors. And antibodies against biomarkers can be attached to the waveguides to obtain a highly sensitive and multi-biomarker sensor. And any biomarkers that would be present in a sample that is then flown across the chip surface will bind to the antibodies and can then be optically detected. Now, these optical chips have a unique combination of characteristics. They allow fast and automated label-free detection, meaning fast research. They have a high degree of multiplexing, which is needed to detect many different biomolecules at the same time. And it is an affordable instrument with a low cost of ownership. And it's this unique combination that will greatly support the development of the next generation of very reliable diagnostic tests. So using this technology, we can accelerate research and make label-free biosensing accessible by offering 4 times more data from the same sample, by providing data points in minutes where other technologies take hours. And this will increase the development of next generation diagnostic tests by at least a factor of 3. And finally, we're able to provide this at a price that is more than a factor of 5 lower than what is currently in the market, and thereby truly making biosensing, label-free biosensing, accessible to anyone for the first time. So where do we stand? In this picture, you see some of our prototypes, which are being used in several locations now. It offers 16-plex detection. It has a best-in-class sensitivity and a proven extremely low bill of material. And these instruments are being used on a daily basis now to develop biomarker assays. And the need for such a platform is already demonstrated by the fact that even though it's still a prototype, there are already a number of academic and industrial partners that rely on our instruments for their research, for their assay developments, and in pilot studies. And we are currently working towards our final product. So that concludes my introduction. Please feel free to contact us anytime if you would like to discuss potential collaborations, or if you would like to perhaps evaluate our platform. Please do not hesitate to contact us. Thank you.
Thank you. Thank you very much, Bart. It was a good presentation, good overview of the products you guys are working on, the technology. I think that's also resonated with the audience. There's a couple of questions here. First one is from Nuno Fernandez. He is asking, so you were able to bind molecular bindings with ring resonators. He's saying it's quite remarkable, but that is indeed what you guys managed to do, right?
Yes, so we visualized the ring resonator. It doesn't necessarily have to be ring resonators, but at least waveguide-based sensors. We visualized them indeed with antibodies that are very specific for certain biomarkers, and then are able to detect these biomarkers very sensitively and quantitatively, so we can really determine the concentrations of the biomarkers in the samples, and do it in a multiplex fashion, so detect many different biomolecules at the same time. Yeah.
That's great. There's 2 more questions. We'll quickly go over them, and then we have to go on to the next speaker because we're running out of time, and Stefan is going to give us a nice keynote. So there's one question: what is the photonic platform that you use?
Silicon nitride based sensors.
Right. And then the last question: who would be the final customer for this platform?
Yeah, the customers would be the scientists in life science research, and that could be people developing We're developing diagnostic tests, the next generation diagnostic tests, but also people interested in research in interaction between two biomolecules. Antibody developers that need to know if their antibodies have high affinity for targets, and even pharmaceutical companies that want to see how well their drugs are able to bind to targets. So it has a broad, it's broadly applicable.
Yeah. All right. Thank you very much, Bart, and thank you for your time today. We'll move on to our next speaker. Our next speaker is Stefan Hengebaas. Stefan is recently appointed CEO at QuiX Quantum. Stefan, can you hear us?
I can hear you. Can you hear me?
Yes, we can. Wonderful.
Cool.
The technology is working again, so let's hope it stays like this. Stefan, you've been appointed CEO a couple months ago, is that correct?
This is correct. So I switched from a quantum startup here in Germany, in Stuttgart, to QuiX now in Enschede.
Wonderful. Well, Stefan, because we're running a bit behind, so I would like to ask you to share your presentation and start. And also to the audience, if you have any questions, you've been doing great so far, put them in the chat and we'll be able to direct them back to Stefan after.
Wonderful. The classical question in the beginning. You can see my screen in full screen mode, can you?
I think we can. Let me quickly check. Yes, we can.
Yes.
Wonderful. Then I try to compress this a little bit. I think you have a lot of experts in the chat and on the line. So we are QuiX Quantum, and we think that we found the fastest way to the quantum future. And of course, you will like this. The fastest way is photonics. And this is already a picture of our core USB of our photonic processor. So we are fabless, but we design, test, and manufacture the box around it, around this tiny little piece of silicon nitride. This is a photonic quantum processor already. It's equipped with some input ports, the fibers on the left-hand side, and some output ports, and some electronics. And here you are. This is already a photonic quantum computer. QuiX has been founded 3 years ago as a spin-out of the University of Twente. The headquarters is still in Enschede in the gallery. And we see ourselves as the market leader in terms of numbers of photonic processors sold, losses, and the quality of the photonic integrated circuits, and the number of modes and their fidelity. I will come back to this later. We have a team of 13 employees at the moment. It's very international, and we are hiring. We just closed our Series A. There will be a press release coming out tomorrow, and therefore now we have the will and we have the ability to grow. Please have a look at our vacancies, and whenever you have somebody in your network who is a photonics engineer, a quantum engineer, please share our vacancies. What are our products? So we started focusing on hardware and developed this 19-inch rack, which includes the photonic processor. And there are some entry ports and some output ports where you as an end user or university can just attach some single photon sources or laser sources and some detectors. This box, so this processor, is available at different wavelengths. For example, the 925 nanometer has been designed especially for working with quantum dots, and the 1550 nanometer has been designed to work with, for example, down conversion sources. There are different processor sizes available. It means a 20 by 20 is a processor with 20 input modes, and it has the depth of 20, which means that all the modes have the ability to interfere with each other. And based on this processor, we went to building complete quantum computer systems. And on the right-hand side on this photo, you can see a complete photonic quantum computer. Again, the processor is the core element. Then you can see in this fridge, there are the detectors. And here on the table, there are the laser sources. And that's it. That's a photonic quantum computer. In this case, it's a boson sampler. It's not a universal one. It will take additional 4 years minimum to have an error-corrected photonic universal quantum computer. But this one here is a so-called special purpose quantum computer, which can already solve some very interesting problems like this one. You can use this architecture that we have to optimize, for example, drug development by a graph isomorphism solver. Don't care about what this is, it's existing, and our processor architecture, this boson sampler, matches very well to this mathematical problem. So there are already some applications. And thanks to the Chinese researchers, we know that photonic quantum computing has a quantum advantage. This was shown in 2020, and there are only 2 platforms available on this whole planet that has been proven quantum advantage. First of all, it's the superconducting quantum computers, and second is photonics. And what you can see here on the table is the setup with, I think it was something between 50 to 100 Q modes that were overlaid in this interferometric setup, everything with mirror mounts, and therefore our Chinese colleagues could show quantum supremacy. This is very good for us. So they have proven that the technology works, but I think everybody from this photon delta community can directly see what we need here is integrated photonics. So no optical assembly on this optical tables anymore. And why photonics? To point this out is very essential. So we don't need vacuum with a processor, and this complete processor, it's made of silicon nitride and silicon oxide. It can run at room temperature. We don't need cryostats, we don't need fridges, except for the detectors. So this is a very mature technology. It's compatible with the CMOS fabs. We have so far the best scalability because we can just use fiber optic technology from the telecom industry. We have gigahertz bandwidth speeds and clock speeds, and something that's very, very unique and very important to me, no special crystals are required. So we have a complete 100% European value chain. Everything we need is silicon nitride and silicon oxide. It's sand and air, and that's it more or less. Of course, there are some challenges. The platform simplicity is one of the challenges. So we need to interconnect a few of the chips once the quantum computer should become larger with more Q modes. And this will be a critical path. The major question is how many chips can you interconnect with fibers or stacking without losing too many photons? And the component count is way higher by minimum an order of magnitude or 2. So we need a lot of sources to be interconnected to the processor core to reach the same level as, for example, the IBM PC has. But all these challenges can be addressed by good integrated photonics and, for example, also by the CHIPS Act. So making 1, 2, 20, 200, or even 20,000 tiny little modules is not a big deal if you are working on a wafer scale. We are also profiting from this photon delta ecosystem. So we're fabless. Lyonix is producing our silicon nitride chips. They are packaged by FIX, and we are doing the design work, the characterization, and we are putting some firmware on the processor itself. And let me just run through it, because this is something you're looking forward, I guess. This is the triplex platform. So this is our USP and the reason why our processors are as good as they are. We are using this so-called triplex waveguide structure, which consists of silicon nitride and silicon oxide. And it can be tailored to have ultra low losses or to have a high contrast. So this is really 0.1 decibel per meter, not centimeter. Keep this in mind. And the high contrast can be as low as 0.05 decibel per centimeter. It's transparent, sorry, this is lithium niobate, this year's triplex. It's transparent in a very, very large wavelength range, and it can be coupled very well to optical fibers, which will become a benefit if the quantum computers will grow to a specific limit. I'll just go over this. There are, of course, some other nice examples of triplex and how you can use it and how the colleagues from Lyonics are using it. For us, a very interesting factor is that you can go from a high contrast to a low contrast mode, even on the chip, and that you can do hybrid integration with triplex. So also indium phosphide modules can be attached to triplex, and this opens up a very, very big toolbox of picking detectors, sources, and different kind of modulators and bring them on one platform. So, and what is this good for? So the triplex platform and our architecture directly comes with the low losses. So this is a comparison of our competitors. That we have, for example, the company Quant, who is using lithium niobate, and they haven't published some numbers yet. There's PsiQuantum, there's Xanadu with silicon nitride, and here we are with triplex. And we have very low propagation losses compared to the others and very low coupling losses. And this results in a very big scalability. The last processor we have demonstrated has 20 so-called Q modes. It's comparable to qubits, but in photonics we call it Q modes. I'll just jump over this. There are, of course, I was asked to tell something more about the photonic integrated circuits. There are, of course, other applications for the building blocks that we have. There's a nice white paper on our homepage about the building blocks and what you can do in terms of phase shifters, interferometers, and so on. And with the same building blocks, which are designed not to lose many photons, you can also build, for example, some photonic circuits for ion trap quantum computers. So, as an example, and I think this is the last thing I will show you because we're really running out of time, we presented this 20-mode quantum photonic processor recently. It has a large number of modes, 20, which is a world record, low losses, a high fidelity, phase stability, which is required for the calculations, and it preserves quantum interference, which means that if we have a quantum state, a superposition, and it passes through our computer, it's still a superposition when it is executing the photonic integrated circuit. So the quantum nature of the light is preserved. And just to give you a brief understanding what we are doing, what is this photonic integrated circuit about? This is a unit cell. So one unit cell in our processor is just a Mach-Zehnder interferometer. We have two beam splitters and a phase shifter. So this is an interferometer, which is able to modify the amplitude. And then there's an additional phase shifter, which can modify the phase. And this is all you need to do quantum computation. And this is the complete 20 by 20 processor with the 20 input modes and the depth of 20. It consists of 190 of these unit cells and 380 tunable elements. And this ends up in something that is at the border to 3 decibel in damping only. So the insertion loss means from the entry to the exit, including the fiber coupling, we have only 3 decibel losses. They're set together by the fiber chip coupling losses of 0.7 decibel per facet, and the propagation losses are 0.07 decibel per centimeter. And this ends up in altogether 3 decibel for the complete processor. And this is already excellent. So this is very good. And we can increase the number of Q modes and bring it to a level where we also can achieve quantum supremacy, which means that this photonic chip will be better than a supercomputer available at the moment. So, and yeah, initially I wanted to tell you something about the fidelity, which is super high. Last sentence to the fidelity. Perhaps this is a nice slide. If you turn on our processor, you will find out that the light will leave the exit ports more or less with an arbitrary intensity. And then we turn on the phase shifters, and we have an automatic software which is able to initialize the phase shifters and save some offsets and tune the phase shifters so that you have this high fidelity, which means all the light that enters, for example, on channel 5, leaves also the chip on channel 5. So in this fidelity, how we call it, is very high. So we measured something like 99.85% for this pure state creation. And I think this was a very, very short walk through my slides. Takeaway message: photonic integrated circuits are very important for us. The losses are the main working point, also the building blocks. In future, we want to have even more building blocks. We need faster switches, and we have to implement even more hybrid integration. But so far, due to this nice ecosystem that we have, and due to all the knowledge around the PICs that has been created, especially in the Netherlands, we can already achieve very good values, and we already have a lot of sales bringing those photonic processors to universities and research institutions.
All right. Thank you very much, Stefan, for your presentation.
Yeah, you're welcome.
It was apparently interesting enough that people kept watching because everyone is still around. Even though we're over time, and of course, our apologies for that. There's a couple of questions, Stefan, that came in. The first one is from Timo, and he's asking, how do you plan to overcome the quantum source problem? You need very good sources to make this quantum processor work.
This is a good question, and this is the bottleneck. So an excellent question. There are many ways. I think quantum dots is one possibility. Down conversion sources is the second possibility. And the third one, of course, you can create sources also on a triplex platform. And this is something that we are already addressing to make our own sources based on ring resonators. And the problem with those sources is that you need a specific overhead. So you need more of those sources compared, for example, to a quantum dot. But since we're working on a wafer level, I think this is not a big deal.
All right. Then a second question, and it was also something I was thinking about actually, is from Tobias. How many Q modes would be required before, let's say, commercial application? He's saying before real world problems could be solved. And how do you deal with the increased heat generation? So let's start with the first question first. How many Q mode? Now you have 20. It's the most powerful quantum processor in the world. Where do you need to go to in order to make it, like, say, commercial?
So you can compare this to the computational power of a classical computer. So the 20-mode processor can be emulated by a standard laptop. It takes a while, but it can be. You can just emulate this. A 50-mode processor requires a supercomputer, and with a 100-mode processor, you're out of that range. So something in the region of 100 to 130 Q modes is more powerful than the most powerful machine that we have on this planet at the moment. So we're close. It's not too far away.
No, exactly. You're right. But and how far, like, say, if you look at the future, how long would it take in order to reach that level?
In terms of the photonics integrated circuit, not too long. But now I have to refer to the first question. I think the bottleneck are the sources. So we have to take care a little bit more about the single photon sources, and this can take a while. If perhaps 2 years or so, then the sources already have catched up a little bit, so that we have more sources available to build bigger boson samplers. But we will have one boson sampler accessible by the web beginning of next year, with just a few qubits, but as a sandbox, and you can play around with it. And whatever works on the little sandbox can be scaled to the larger ones later.
All right, good. Then let's see, the additional question from Tobias was, when you increase the number of Q modes, how do you deal with the extra heat that's generated?
It's Not too much heat, by the way. We are using at the moment, we're using thermal phase shifters, which become a little bit warm. But it's problems like crosstalk are solved. You can just increase the cooling power a little bit. But you can also use different kind of phase shifters, also addressed. So there are a lot of technical possibilities that heat is not the limiting factor. It's more losses or sources. So we're not taking too much care about the heat problem.
Yeah, so it's more about the decibels and the single photon emitters.
That's true.
And it's also because you're using photonic integrated circuits. So because you're using light, you have less heat generated, which is also what you were pointing out in your presentation.
Mm-hmm.
Yeah.
Correct.
All right. Then I think there's no more questions. I would like to thank you very much, Stefan, for your presentation today.
Thank you.
And we look forward to the upcoming news about the investment, of course. I think it will be released tomorrow, if I'm not mistaken.
Tomorrow, 9 o'clock.
Right. Okay. So looking forward to that. And well, of course, keep on the good job and wish you all the best there in your new role at QuiX Quantum. Then we will continue to the conclusion of this session. So first of all, if you have any feedback on the concept of the program, on the content of it, or if you have ideas for the next one, you can scan this QR code, or you can simply visit the Photon Delta website and go to the Delta Dialogues page, where you have access to the forums. You can drop your ideas, share your feedback, which will help us to improve this for you in the future. Now, this was the last edition before the summer holidays. In August, we will not do the Delta Dialogues, but we will be back to you in September. Every first Wednesday of the month, which means the 7th of September. Expect, again, a nice program with engaging content that is tuned to the integrated photonics community. And with no further ado, then I would like to conclude this session. Again, apologies for the delay, but I hope everything was interesting for you. I see that still a lot of people are around, so that's a good sign. Then I wish you a great summer holidays and see you back in September. Thank you.